Now we have to start applying what we know about scattered plots, and we have to start thinking about them logically. So let's say we have a scattered plot, and the data is kind of like this, with, scattered around. Now this data set kind of looks like an X. So there are technically two possible lines we could draw to represent this data. We could draw one like that, or we could draw one like this. Now obviously this one has a negative slope, this one has a positive slope. But determining which slope is better to use to represent your data is totally based on what you know the data is technically supposed to represent. So if you know based on your numerical data that there really was a trend that, let's say, as age increased, sleep increased, okay, then you're going to want to pick this slope to represent your data because it is most like the trend you were most seeing in your numerical data. Now, how did I write these lines if it was scattered data? What I just did was something called the line of best fit. If there is a bunch of data that kind of looks like a line, but really isn't like a line, what you're going to do is you're going to find where on the line you have the same amount of points on top as you do on the bottom. So 1, 2, 3, 4, 5 are below the line, 1, 2, 3, 4, 5 are above the line, and the center is kind of around here. This line right here best represents the data. So when you plug in any value of x from this ordered pair to find the value of y, so let's say we have our age here and sleep. Let's say we go to 20 years old, and that is going to lead to 9 hours of sleep per day. So when you know your x value, you can easily find your y value. That's why it's important to find, because this line of best fit is going to fill in the values that we can't find in the data. Now, obviously this line of best fit is off from a lot of the data points, and that's okay. We're trying to look for an approximate point. What we're going to eventually learn is that there are ways to see how far off your data plots are from your line of best fit and if it's a good or bad line of best fit. We know that this line is off from most of the dots. The difference from the line to the dot is known as the residual. To find the residual, what you have to do is you have to take, what the residual is it's basically your prediction error. This line is a prediction of where your points lie, and this is where the actual points lie at that x value. So your difference in the line and the point is known as your residual. If the difference between the line and your point is small, then that basically means your residuals are going to be close to the line, and it's a fairly accurate line. If the residuals are bigger, that means that the points are going to be farther from the line and therefore less accurate of a line. Now, just to clarify something, the residual is the actual y value minus the predicted y value. Okay, and what this means is that when you have your line and your plots are like this, if it's below the line, your predicted y value is going to be less. So let's say this is 1 and this is 3, so you're going to get 1 minus 3, and that's going to give you -2 for your residual. So that just basically says that it's 2 points lower. Anything lower than the line is going to be a negative. Anything above the line, let's say this one were also 2 points, anything above the line is going to give you a positive residual. Hey, thanks for watching this Crash Course video. To watch the previous video in this series, click here. To watch the next video in this series, click there. If you want to request a video, make sure you put it in the comments below. And don't forget to subscribe and like this video.